In number 10, we're going to take a look at the diagram and use what we know about the hinge theorem, or the converse to the hinge theorem, in a more real-world situation. So you have these paths laid out, and we've got the corners where they meet labeled. Here's E, D, G, and F, and then we're given some information about it. So we know that the path from E to F is longer than the path from E to D. Now that is information, I can't really mark it yet on the diagram. The other parts of the information that are given to me I can mark. The path from G to D is the same length as G to F. So G to D, this segment in here, is the same as G to F. Okay, so when I'm talking in terms of triangles, those two line segments are the same. The other thing that's not mentioned in here, but that you know from looking at diagrams of just triangles, is that this side, EG, is the same in both triangles. Okay, so again, I have a scenario here where I've got two sides from this triangle that I know are the same length as two sides from this triangle. And so now we can really talk about the angles that are included in between those two sides. Here's where I'm going back to the initial information that's given to us. This path, EF, is larger than this path. I don't care what it is. I don't know exactly what it is. Let's say that this one is 15 meters. I'm just marking this randomly now. But as long as it's larger than this, we'll mark this one as 13. We now have two sides here congruent to two sides here, and I'm trying to talk about this included angle. Since this one is smaller, since this side, this opposite side is smaller than this included angle, this angle must be smaller than this angle here, because the third side, the opposite side of it, is larger here than it is here. Okay, so based on that given information, it's safe for me to say that this angle, DGE, is smaller than angle EGF.